What's up, guys? Welcome back to the podcast. We got David Rames from Midea, and he's going to take us through another two-part conversation. I love these two-part conversations. They work really, really well for my podcast in this format. But he's going to take us through, in the first episode here, are heat pumps with inverter technology, are they that complicated? What do we got to do to make that complication sort of go away? The other thing he's going to discuss, and I've been through as well, is the oversizing of furnaces for the last 2-3 decades. It's a problem, right? We're just starting to get to the proper sizing of equipment now with all the information that's coming to us, I think. So let's get to this, guys. It is the HVAC Know-It-All podcast, and I'm your host, Gary McCreadie. This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out. All right, David, you kind of said something that I giggled in my head. I didn't giggle out loud when you said it, but you said Grandpa's heat pump. What is Grandpa's heat pump, first of all? Explain that to us before we get into the conversation.
So years ago, and actually not that long ago, heat pumps just didn't do well in extreme cold climates, right? So, if it was 50 degrees outside and you needed a little heat in there, it would work. But boy, once we got down to that 40-degree Fahrenheit or below, it started putting out some pretty cold air because that technology back then just couldn't take the heat from outside and transfer it inside. So it struggled. And so people froze to death with a heat pump and temperatures at 40 degrees less. And we have come a long way through technology to make sure you're getting great heat output with the modern technology and the modern compressors that we use.
Mm-hmm. Okay, so I agree with you, and I've seen it with my own eyes. I've seen it because I'm in Canada. I'm not like in northern Canada. I'm actually in Toronto, which is actually more south than quite a lot of the US when you look at it on a map. But the argument about heat pumps, especially on social media, is alive and well because it's like the information hasn't gotten to everybody that heat pumps actually do work in a cold climate atmosphere. Now, I do want to ask you a question because some do know that they work, but they have an argument, and I'd like to hear your side of the argument, that they're too complicated, they're too sensitive with the circuitry inside, and they're too expensive. So let's tackle each one. Too complicated is the first one. What do you say to that?
Well, it's up to manufacturing, right? And at Midea, we've got this group of experts. The one thing we do that's a little bit different than maybe a lot of people is we involve contractors in everything that we do. So we know that they are the base of our success or our failure, right? So if these products are easy to install and easy to service and easy to troubleshoot, then they'll go, boy, we need to do more of this, right? Especially if the performance is as good. So when we actually bring in, we do hundreds of thousands of dollars of consumer research, and a lot of that involves contractors. And so we help them. You help us to build a product that's easy for you, more of a plug and play type scenario, communicating or 24 volt. And if you make it easy and you're happy with the product, then we actually take that feedback from the contractors and then we implement it into our research and development process. And if the contractor's happy, that makes us happy. So we kind of start at that level, make it easy for them. And so contractor fingerprints are on every product that we have. And so we're super happy to get the feedback from those guys to make their lives easier.
Okay. Now, my take on it is that a lot of the people that say they're too complicated, they're looking at it from outside. They don't actually have their hands on it yet because they're seeing these things in videos and online and websites and stuff like that. And they're like, wow, like it looks super complicated to work on that thing because it's all circuit boards inside of it. My opinion is some of these people haven't even gotten their hands on it yet. And that's just what their assumption is. It's just their opinion. It's not actually based on facts. That's some of the people, sure. Because they're used to a contactor and a capacitor and a compressor in a condensing unit. And that's like, for them, that's life. But sometimes stepping out of your comfort zone allows you to learn and progress in the trade. To me, I think it almost makes it easier in a way, for me anyway, when it comes to troubleshooting. Because if you've got a circuit boards for me is you got your power in, you got your logic in the middle, and then you have your power out, and you got inputs from different sensors and stuff like that. So if you got your power in, your sensor inputs are all correct, your logic is correct, but you got no outputs coming out of there, then your board, it needs to be replaced. And that's an easier fix than replacing a whole bunch of parts in a lot of cases, right? It's just take the plugs off the board, put the new one on, put the plugs back on, and away you go. So too complicated, it seems like an excuse to me, from some people anyway. And I think once you do several of the same brand, then it just becomes like second nature. Like you've read the manual several times, you've done it, you've seen it work, you've done trial and error with different things, and now you're off to the races. But you got to get your hands dirty in order for that to happen. What do you think?
Absolutely. And so one of the things that we do is we make sure that our training regime is consistent and rigid. So even those who had experience, please come. And we travel like crazy and go to our distributor partners across North America. And, when we first started this, we train the trainers, right? It's our distributor partner trainers. But then we thought, let's take this a step further. Please bring your contractors in. Because, that does two things, right? So that not only the contractors can hear it right from the horse's mouth, which is the manufacturer. And as we develop these products, we've got a full tech support team, and they are in our research and development process. So we want to make sure that they know from a contractor perspective how easy this is to install and to service. But when we do the training, we welcome questions, welcome concerns. We want to be challenged with the product. And as we talk through this, then they get more comfortable with it. And we go all the way through installation and again, in the troubleshooting and error codes, because when we build this system, it's filled with sensors, right? And so the bottom line is, if you don't have an error code, it's not an equipment problem. It very well could be an application problem or an installation problem. And if there's not an error code, probably should check the installation or the return or the supply or something else.
Okay, cool. So just so the audience is aware, later in the podcast, I'm going to ask you about how we overcome the challenge of heating in really cold climates with today's technology. So I'm going to ask you that in a bit. But I want to get back to the 3 points that I made earlier. So the other point people make or try to make is that today's heat pump with all the circuitry on board is too fragile. I've changed out a lot of circuit boards in my life. Yes, in different things, furnaces, rooftop units, heat pumps, you name it. But what I think is part of that problem is power fluctuations. And that's why today, everybody that installs anything that has a circuit board inside of it, it's recommended that we do some voltage monitoring and surge protection, and that will mitigate, I don't know what the percentage is because I haven't looked at a study or anything like that, but that will mitigate a lot of the problems because you have that added protection, because you don't want to put too much voltage or not enough voltage or have a lightning strike in the area and have a surge take out a circuit board. If you have this protection in place, I think we can mitigate a lot of these problems. What do you think, David?
Absolutely. And we welcome surge protection, right? So, the old insurance policy, right, which is the surge protector. And there are areas where the power is consistent and it's clean. And even without one, you wouldn't have a problem. But it seems like once you get out in maybe a rural area or a co-op area with inconsistent or maybe a little dirtier power, for us, having that surge protector on there, not a problem at all. If it's that extra layer of protection that makes everybody feel good, again, like an insurance policy, please use them, and we welcome that on our system.
Okay, cool. So that's easy, and I've talked about that tons of times, and I've been on installs with other contractors that have been putting them in, and I've been like in the background, kind of just fist pumping because they're actually doing it correctly, and they're not going to turn around and blame dirty power or a surge on the equipment, because that's what happens, right? The equipment goes in, it's not installed right, it's not set up right, and then the service tech goes back and he calls the equipment a piece of shit because the installer didn't install it properly. And it happens all the time, right?
It's always the equipment's fault. Always, if it's not the installation, it's always the equipment.
And I'll be honest. I mean, I'm sure every manufacturer in the world has a lemon or two that comes off the assembly line, and that does happen. I'm not going to say it doesn't because I've witnessed that myself. But more times than not, when it's not running correctly, it's something to do with the installation. So to my next point, too expensive. The argument is why would I put in a fancy heat pump system that costs more than throwing in a furnace and an AC, and it does the same thing. At the end of the day, the end users got heat and they've got cooling. And there's a lot of arguments online that it's running a heat pump in the winter. Yes, it will heat a home, but at what point is it drawing too much power consumption over what you're going to pay for a natural gas furnace? These are all valid arguments. And I think it differs from area to area, to be honest with you. Give me your take on too expensive for the upfront capital install of a heat pump in a residential application anyway.
Yeah. And so they're not wrong. I mean, there are areas, and we do studies, and we've got a data scientist here who pulls, and he's amazing, pulled like the average price per kW and price per therm all across North America, right? So when we look at that, and we see an area where the cost per therm for gas is extremely low, but the price per kW is very high, that may not be the best application, right? But what I can say is, and even in my own house, I've got a 4-ton Midea extreme heat and a Midea coil and a gas furnace in my house. And so whether someone talks about electrification or decarbonization or whatever, even if you go dual fuel and the power of today's heat pump, and you're worried about fossil fuels and you don't want to use them, you can still use it, because in my house, my heat pump runs 99% of the time. You can change the balance point on that. But what I feel in my house, and the feedback that I've got for others who have done either straight AC and gas furnace or a dual fuel system with a heat pump, is almost all the time that gas furnace is oversized. And we've done consumer research where whether it's an AC, a heat pump, or a gas furnace, 80% of the installs are oversized. So then we lead to short cycling. So even on the gas side of things, and before I put in this system, I was air conditioner and gas furnace as well. But the gas furnace, it seems on, off. So, it's the whole, is it hot in here? Is it cold in here? Is it hot in here? Is it cold in here? Where a heat pump that works correctly and has this cold climate performance will give you that, the exact amount of heat you need as we modulate to the low or the heat loss, heat gain of the house. And we modulate on that all day long to keep a consistent temperature, to kill that short cycling and make you more comfortable in the process. Probably save you a little bit of money as well. But we sell comfort here. And if folks, again, if the KW in your area is super high and the therm super low, then maybe you can use that gas furnace a little bit more. So it really is geographical, but we do have the performance on the heat pump side to take care of you if you need it.
Yeah, so you mentioned comfort, and I brought this up before, is comfort. People have a monetary value exchange probably in their head. Not everybody. There's some people that are on a budget and it's just like, please change the box in my home and get me heat again. But there's some people that you walk into their homes, and certain rooms or certain pockets of the homes are colder or warmer depending on what season we're talking about. And that is because, like you said, most of these systems are oversized and they run for 5 minutes. The thermostat cycles off, but the air hasn't had enough time to slowly mix and move around the home and actually heat the home. If you get online and talk to people, there's an agreement that ductwork is undersized in a lot of homes in North America. But what I'm starting to think instead is not the ductwork that's the problem. It's the equipment. It's too big. It's trying to move too many CFMs through the ductwork that's already there. And then when you actually do a load calculation and reduce the size of the equipment to what it's supposed to be, the ductwork is not a problem anymore. It's not a problem. And I've witnessed this on several occasions. I'm sure it's still a problem in many applications as well. But what I'm noticing is the ductwork, the original ductwork, is sized right, but the equipment is just trying to move way too much air through it, and the static pressure is through the charts because of that. But I do see people putting value on comfort. Look at some of the vehicles people drive, right? They drive these vehicles. Some of them drive them for show to look cool for other people, but some of the people drive them because they want absolute comfort as they drive to and from work or to their kids' games, or if they're driving long distances for vacations or whatever, they want that comfort feel, right? And people pay top dollar for a vehicle. So why aren't people paying top dollar for, or why aren't some people paying top dollar for comfort? Is it because it's not a social status? Is it because it's hidden in your basement or in the back of the house and nobody actually sees it? Like, what do you think? What do you think that is, David?
I think all of that. So,
Yeah.
it's not a stainless steel appliance, and it's not a granite countertop, and it's not an oak cabinet, right? So for me, it's sexy, but for a lot of people, it's not. But we learned a lot of things through COVID, but something very valuable, which when people were home at 2 p.m. on a Tuesday in July, when they normally weren't, they felt really how uncomfortable that house was when it would not keep up. And to your point, people don't really know what comfort is. They say, no, that room has always been 7 degrees warmer than this room. That's just the way it is. But it's not the way it has to be. So you're right. When the system is oversized, and I'll give my house as a perfect example. I've got 110,000 BTU, 80% gas furnace in my house. Okay. But I've got a 48,000 BTU extreme Midea heat pump. So my 48,000 BTU is putting out 48,000 at negative 4 degrees Fahrenheit. So I've got enough heat as we transfer that heat from outside to inside to keep my house at 72 Fahrenheit. Only in extreme cases does my gas furnace ever kick on. So if you think about that, at 48K at even say 5 Fahrenheit, I'm keeping my house at 72. I know that furnace is going to short cycle. So again, hot, cold, instead of just this consistent heat transfer from outside to inside, that's really where comfort comes in. And by the way, it is a quieter system as well, because the heat pump is going to vary. The compressor is going to run at minimal capacity as long as it can. So the heat pump can do the job for sure.
Mm-hmm. Okay. Now, I want to talk about how important, because you did mention that Midea does manufacture 24 volt as well as communicating systems.
Right.
Can we maybe talk about the difference between the two? Because there's some people out there that don't understand the difference between communicating and 24 volt system.
Yeah. So what we try to do is we always want to provide options. So whether it's our Midea EVOX, which is a system we've had for a couple of years now, or it's the new EVOX, Midea EVOX GQ system with our new modular air handler and all of that, they can go both ways. So with the new system, it actually, if you're going to use a Midea communicating wall control, it will say, okay, I see I'm communicating. We've got 2 wires, HA and HB from the air handler to thermostat, and 2 wires, S1 and S2 from the air handler to the heat pump. It automatically recognizes that we're using communicating wall control. So we constantly, indoor, outdoor wall control, we're constantly sending information back and forth. Outside air temperature, inside air temperature, cycle rates, all the sensors in the system are constantly communicating. Now, because we want to provide options, and let's say a homeowner just bought an Ecobee or a Honeywell or an Emerson wall control 24 volt, and they say, I'm sorry, I love this thing, I love the app, you're not going to take it from me, then we go, okay, we can use it. The system will automatically recognize it's being run with a 24 volt thermostat. You will lose a little bit of the functionality on the inverter and the variable speed, not a lot. I'm running my system at home on an Ecobee, it runs great. So you'll lose a little bit, but if that's where they're comfortable, we really don't want to force them to change that wall control, since that's the user interface in the app and that's what they're comfortable with. We've got options to be able to keep it wide open for them. We never want to lose the opportunity because they need to change that wall control to communication.
Mm-hmm. But with the communicating control, correct me if I'm wrong, and you did mention it a little bit, you're going to get a little bit more out of that machine because the compressor and the fan speed can match up together and stuff like that. Is how important is that? Do you feel? Because I mean, I've put in communicating systems as opposed to 24 volt as well, and the 24 volt system is on off. The communicating system is more like, let's take this information and continuously change things up a little bit to match what it is outside as opposed to inside and all that kind of stuff too. But with 24 volt, and if it's a standard furnace, like you're running dual fuel, the furnace doesn't really know what speed the compressor's at. So it's not really matching, right? So what effect does that have on capacity and comfort if you go that route? Or if you don't go that route, sorry.
And so we're not communicating all the time, right? So
Yes.
it's put constant signals between indoor, outdoor, and wall control. It probably on the 24 volt, it will cycle a little bit more, right? Because, again, the fan on the third party unit does it know, or even our unit. Most people, honestly, though, when we put in our system with 24 volt, because they're so used to single stage products at 24 volt and DOE minimum efficiency, they see a major upgrade, but they can't really tell what it's doing because they've never had a true communicating system. So you lose some communication. You may cycle a little bit more, right, because of that communication loss. But again, if that's what they want, the last thing we want to do is force them to put a wall control on the wall that they're not used to, because sometimes old habits are hard to break, right? So we don't want them to have to do that if they don't have to. But again, the lack of communication between indoor and outdoor, the wall control, constant communication, fan speed changes, compressor changes, and all of that. Communication is the best way to go, but we always want to provide options for that as well.
And that's what I wanted to hear you say is communicating gives you the most optimal control over the system, right?
Absolutely.
Okay.
And we were actually, earlier this week, we were training one of our Midea master distributors, and we broke down the difference between the 24 volt system and a communicating system. And we had a room of about 45 people, and they said, why would we ever go 24 volt on your system? And I said, I'm glad to hear you say that, because that is the right answer. And the other thing that it allows us to do is, with the communicating wall control is, if we find and we want to sharpen up or fine tune an algorithm, whether that's compressor or fan or whatever, we can send an over-the-air update to the communicating wall control and just automatically change an algorithm or a speed or whatever, and you don't even know what's happening. And that allows us the opportunity to tap into that system to make sure we maximize your comfort and your efficiency, your noise, all of that, just through an over-the-air update, which we can't do through a 24 volt wall control.